When working with a quadratic function, you may not always want the standard form for your analysis or graphing, whatever it is that you're trying to do with your equation. So there's another form which is 100% equivalent to your standard form. It's just, again, a different form. It's called the vertex form. And the vertex form is recognized by the following equation: f of x equals a times x minus h squared plus k, where the a, h, and k are all real numbers, and again, a is not allowed to be 0. So we've already investigated a little bit about why a can't be 0. We saw that in definition 12.1. So we'll leave that to rest for now and focus more on the a, h, and k. So I want to create a quadratic equation using a, h, and k, and I'm going to let a be equal to 2, h be equal to, let's say, negative 3, and k is going to be equal to 5. So now I have f of x is equal to 2 times x minus negative 3 squared plus 5. And then here on the inside, where it says x minus negative 3, I had to plug in negative 3 for the h, but since I'm subtracting a negative, I would simplify this just a bit and call it 2 times x plus 3 squared plus 5. And this represents a quadratic function equation written in vertex form. Now, the first note that I have here says that this is also known as the transformation form. And that's really important for us to see, because everything we did in section 4 about transformations, that would be shifting left and right, shifting up and down, stretching, shrinking, all that stuff, reflections, it all applies, all of it. So what you'll notice is here in the parentheses you have this x plus 3. That's all being squared. So this would indicate that we are supposed to have a horizontal shift to the left by 3 if I was following the rules of transformations. And notice that your h was negative 3. That would imply going to the left. The plus 5 is the same as your vertical shift. We would have a vertical shift up by 5 because of the k value there. And then the final thing that we have is this 2. And this 2 would indicate to me that I have a vertical stretch or shrink. And I can say specifically that it's a vertical stretch by 2 because the value of that multiplier is greater than 1. So it might be worth going back and looking at some of the rules for transformations, so that way you can determine what type of stretch or shrink you're going to have, as well as the rules for horizontal and vertical shifting. The other interesting thing about the vertex form is the reason why it's called the vertex form. It's called the vertex form because the ordered pair h comma k is going to be an element of your function. So let me make a note here that this is supposed to be a ordered pair. It is not meant to be an interval. It is an ordered pair. And this ordered pair represents the vertex of the graph of your quadratic function. On definition 12.1, we had talked about the squaring function, f of x equaling x squared, which is a type of quadratic function. It's the quadratic function where a was equal to 1, b was equal to 0, and c was also equal to 0. It's the most basic quadratic function equation that we can create. Now, if I was to look at the graph for this, just a crude drawing, would have the vertex located at the origin, and then the parabola would open up something like this. So anytime I have an h or a k that is in my vertex form, then I'll be taking this basic picture and I'll be shifting it left or right or up or down. So that means that the vertex is going to have to go left or right or up or down along with the rest of the function. So the value of h and k ends up taking on the exact location of the vertex when it's written as an ordered pair. So it's really convenient to have this vertex form because you automatically get the location of the vertex for free. And it's, in my opinion, the vertex is the most important point when graphing a quadratic function. So there will be times when you are directly given the vertex form, and there'll be times when you are given the standard form. So it'll be important for us to practice going in between the two forms, standard form and vertex form, vice versa, depending on whatever the application or the situation calls for.